In this session, we are going to study another issue for clustering assessment called cluster stability. Cluster stability basically say whether you got the right parameter, you get the very stable clustering results. That means you can assume you get a data set D, you take a sample, get several data sets from the same data set D, you do the clustering. And you should assume if your clustering finally get a very stable clustering results, that's a good clustering. Usually you can use this to find good parameter values for a given clustering algorithm. For example, you can find a good value of K, which is a good number of clusters. So how do you find this? You probably just look at this graph, you probably can see. If you set K as 3, or even as 2, you probably can find quite reasonable clusters. But if you set as 4 or 5, no matter how smart you are, probably this cluster you find may not be quite stable. So to that extent, you may try to test the cluster stability. We introduced one method called bootstrapping approach to find the best value of K judged based on stability. How can we do this? Okay. This bootstrapping basically say from D, you take T samples of size N, but the sampling is sampling with replacement. That means every time you take almost from the same D, you take it T times. Then you get the sample D sub 1, D sub to D sub J to D sub T. Okay. Then you run the same clustering algorithm with K value from 2 to the maximum of the K you like. Okay. Then you can compare the distance between all the pairs of clustering. For example, for each K, you may try to see whether the D sub I and D sub J, these two different sample data sets, you will see whether finally you get the sample, you want to compute the expected pairwise distance for each value of K. That means suppose K you get a 10, you get these 10 clusters, you want to see their pairwise distance. Okay. Then what you can see is this value K, if it exhibits the least deviation between clustering. That means you do clustering on the sample D sub I or sample D sub J, they have the least deviation. Okay, that K should be the most stable one. That's, you may want to have this K value. So that's one application to test the cluster stability to find the best K. Actually, there are many methods to find the K, the appropriate number of clusters. One method called empirical method, actually people give you this empirical formula. For example, for total data sets of n points, you may take the square root of half of these n points. Okay. For example, if n is 200, the expected value you need to get number of clusters should be 10. Of course, this may work out for a small number of points. If you get a really big number of points, for example, you get 2 million points, then you get this value, you will get a K is 1,000. Probably you may not want to get 1,000 clusters even for 2 million points. Another method people use called arable method. Arable method means you try to, based on the number of clusters, like 1, 2, 3, 4, you get number of clusters. Then you get the sum of the within square variance. That means you just look at the average of within cluster variance. You try to look at this to see, what is the best number of K that you want to see the arable point, the turning point. So that's one method. Another method finding the best number of K is use cross-validation. That means you divide a given data set into n parts. So you take one part as a test data, the remaining part to do the clustering. Actually, you can do this m times, so you can check their overall quality of the clustering. Okay. Then how we test the quality of the examples? Okay. What we do is, suppose we use this m-1 parts to do the clustering, we find k clusters. Then for each point in the test data set, you try to find its closest centroid. Then you, based on this, you try to find, for all the points in the data sets, you try to find the sum of the square distance. That means you try to find the sum of the square error SSE as we introduced. Then usually you try to see whether you get the best fit of the test data sets. That means you get the smallest sum of square distance. Since for cross-validation, you repeat this m times, so then what you can do is you can compare the overall quality measure with respect to different case. Then you find what is the best number to fit the data best. That means you get the overall quality measure, you get the lowest SSE for this particular K. You say this is the right number of clusters.